Okay, so I'm gonna try and finish going over the homework that we started in class today. And then I'll post it to Emoto. But if it's too big, then I have to post it to YouTube like I did the last time. Alright, so we started 9. We did A, which was find the slope. We did B, which was find the tangent equation. And then we did C, which was find the normal equation. And D was to draw the graph. In the same viewing window. Alright, so we need to draw our curve, which was x squared. So, and again, not sketch, draw. So I'm going to press second and graph to get some ordered pairs. And I'm going to make sure I include the point that the original problem wanted us to include. So, -3 and 9, -3 and 9. -2 and 1, 2, 3, 4. And then -1 and 1. 0 and 0. So curve, you usually want to do about 5 points. You want to do the axis of symmetry, which in this case is y. And then you want to do some points on either side of our axis of symmetry. But we're not sketching, we're drawing. So when you draw, you need some points. Alright. So then I'm going to press y equals, and for x2 I'm going to put my tangent equation, which was -4x minus 4. And tangent equation means it's going to hit our curve at least one time. You can barely see it. Let's see if I can change the color. As you can barely see that. Let's see. See if that's better. So that's our curve. And that's our tangent equation. All right, that was a little bit better. And so, again, I'm going to use the point in the problem. The point in the problem was -2 and 4. So I'm going to press second and graph. And here is our tangent table. And as you can see, here's -2, here's 4 and 4. That means that's where our curve is touching our tangent equation, or vice versa. And then when x is -1, our tangent equation is 0. So -1 and 0. And then 0 and -4. And then -2 and 4, which we already have, that's here. And -3 and 8. That's here. And so I need a ruler, which I don't have, but all right. And then okay, so now we need to graph our normal, or perpendicular, and I'm going to try to put it under a darker color, maybe this brown down here, because it actually doesn't matter where you put it. Let's try this. 1/4 x plus 9/2. Oh, okay, there it is. Alright, so this is our perpendicular, or our normal. Okay, so I'm going to press second and graph. And I put it under 7, so here it is down here. So here's -2, and our curve was 4, our tangent was 4, and our normal is also 4. So I tried to make that a little darker than all the rest, since that's the point of where we want our slope. And I just need another point for my normal, and I don't like these decimals, so I'm gonna come down here and get 2 and 5. So let me move this over a little bit and get 2 and 1, 2, 3, 4. So 2 and 5. And that will be that. So this is my normal. Let me move this. Normal. Here's my curve. And here's the tangent. Okay. And that would be about it. Okay, so here's number 11. Again, we started in class. We found the slope for A. B, we didn't finish, so let's go ahead and finish. And so that's how we get y equals negative x plus 3. And then the same thing for our normal. And that's how we get y equals x minus 1. And then let's draw our graphs. I'm going to put 10 on each side and make it fit. If you want to use graph paper, you are more than welcome. It'll look neater. But you should have some points. It should not be a sketch. Okay, so I'm going to come here and take out all these graphs. Alright, so our curve is 1 divided by x minus 1. So let's see what that looks like. Okay, so it has a vertical asymptote at 1, so it's curving, so that's why we call it a curve. So let's see what our points will look like. Our point that we are using to find the tangent and the normal is 2 when x is 2, so y is 1. So we're definitely going to use that. X is 2, y is 1. And and then here we have, what is this? 0 and negative 1. And then at 1 there's the error. Alright, and then at negative 1 it's half. And then at negative 2, so we're going so here's our vertical asymptote. And then I need one more point here, so I got 2 and 1 and 3 and a half. So it's gonna go like that. Alright, so that's our curve. This piece of our curve should not touch the x-axis as much as possible, or I should say period. And then this piece of it should not touch the x-axis. This piece here should not touch the vertical asymptote, and this piece here should not touch the vertical asymptote. Alright, so here's our curve, and then our tangent. Yeah, again, try to use the darker colors. So we have negative x plus 3. See what that looks like. And it's hitting it at 2 and 1. So we know 2 and 1 is an ordered pair. And since this is a line, I just need one more ordered pair. So 2 and 1, we know that that's an ordered pair. And then 1 and 2, we can do that. And then 3 and 0, so that's like about right here. So yeah, this would be a lot better with graph paper, but gotta work it out. Okay, and then finally our normal. Again, I'm gonna just put it down here for one of the darker colors, x minus 1. And this is all of them on the same coordinate plane. Window is a 10 by 10. Alright, so again, we know that 2 and 1 is going to be our intersecting point, because that's where the problem wanted to know where the slope was. Alright, so we just need another point. Wonder if 0 and negative 1 is another point. So let's look at it. 0, yeah, and negative 1. There's the other point. So I'm just going to draw that. And then label everything. This is y equals x minus 1. This is y equals negative x plus 3. And then this is y equals 1 over x minus 1. And there you have it. Alright, so moving on, let's look at 13. But we also finished 13. We just had to remember that when x was 2, it's positive, so the absolute value is positive. But here x was negative 3, it's negative. So we had to, the only way to make this x negative, the only way to make this 3 negative is if the function became negative. Past that, it would be positive, because absolute value is always positive. Okay. All right. All right. The next problem you all wanted to see was 17. All right. So alright, so number 17, it says, determine whether the curve has a tangent at the indicated point. If it does, give it slope. If not, explain why not. So here's the function. f of x equals 1 over x at x is less than or equal to 2. Then we have 4 minus x over 4 at x is greater than 2 at x equals 2. So the only way that this would have a slope at the indicated point is if the slope is the same on both sides. So this is the left side because it's less than, and then this is the right side because it's greater than. So you're going to take each of these equations, plug it into the slope formula when x is 2, and if they're the same, then that slope exists. If they're different, then that slope does not exist. So basically, it's the same thing we did in 9, 11, and 13. Just getting more practice with this so you can get comfortable with it. All right, so left side limit right side limit. All right, so the left side is y equals 1 over x at x equals 2, and the right side is y equals 4 minus x over 4 at x equals 2. So let's do the left first. So we have the limit as h approaches 0. Write the formula. And then plug in x. And then plug this into the formula. Then you would plug this into the function. So plug this into the function, plug this into the function, and all of that would be over h. So this would be 1 over 2 plus h minus 1 over 2 all over h. And so common denominator is everything that's different in the denominator. So 2 plus h is different from 2. So that's our common denominator. So our common denominator is 2 times 2 plus h. Again, don't multiply it together. It does you no good to do that. So leave it separate so you know what to cross out. So this is 2 times 2 plus h. This is 2 times 2 plus h. And then this would be 2 times 2 plus h. Alright, so this has a 2 plus h, this has a 2 plus h, so it's just 2 left, because 2 times this 1 is 2. This has a 2, this has a 2, so it's negative 1, because it's minus sign, it'll be a negative 1 times 2 plus h, so that'll be minus 2 minus h all over h times 2 times 2 plus h. That cancels. Something should always cancel. And we get the limit as h approaches 0 of negative h over h times 2 plus h. That reduces. So we get the limit as h approaches 0 of negative 1 over 2 times 2 plus h. Now we can plug the 0 in. So this would be the limit as h approaches 0, negative 1 over 2 times 2 plus 0. And so 2 plus 0 is 2, times 2 is 4, so this slope is negative 1, 4. So the left side is negative 1, 4. So we need to do the same thing to the right side. And if it's also negative 1, 4, then the slope exists when x equals 2. Okay? So it didn't ask us to do a tangent or a normal, but we could because the slope, if the left side and the right side are the same. If they're not the same, then we can't. So we have to see. So let's do the right side. Alright, so this would be f of 2 plus h minus f of 2. So everything's the same so far. But now when we plug in this f, when we plug in 2 plus h, we're plugging it here. Because this means everywhere you see an x, put 2 plus h. So this would be the limit as h approaches 0 of 4 minus. Now plug in this 2 plus h. Over 4. Because you have to finish off the function. Minus. Plug in is 2. So this would be 4 minus 2 over 4. And all of this will be over h. So now let's simplify this. So this would be the limit as h approaches 0 of 4 minus 2 minus h all over 4 minus, and then 4 minus 2 is 2, and then divided by 4, so it's 2/4. Now I know that's 1/2, but because this denominator is 4, we're going to leave it for right now because that'll make simplifying a little bit simpler. And this is all over h. So then we have the limit as h approaches 0. So this is 4 minus 2, which is 2 minus h over 4 minus 2/4 all over h. Alright, so because we left it as 4, that's our common denominator. And we actually can combine it because it's our common denominator. So remember, when the denominators are the same, you can add or subtract the numerators. So this is actually 2 minus h minus 2. Well, you can do that because the denominators are what? The same. So we get the limit as h approaches 0. So that actually cancels with that. And then we get negative h over 4 over h. And I know that looks funny, but it shouldn't be too big of a deal because this is just negative h over 4 divided by h. So if we just rewrite it, it's just negative h over 4 divided by h. Now there was another way we could have did this, but it's okay. So we don't divide fractions, so We multiply by the reciprocal. So we have the limit as h approaches 0 of negative h over 4 times 1 over h. Which you can, well, you all say cross cancel, but it's simplifying. That simplifies with that, and then this becomes negative 1/4. Okay? These problems will really test your algebra skills. Alright, and so you conclude, since the left and right slopes are the same at x equals 2, the slopes exist, which is negative 1/4. Okay, that was a lot going on there, but we did it. Alright, so the next problem you all wanted to see was 27. Alright, so it says free fall on Mars. The equation for free fall at the surface of Mars is S equals 1.86 t squared meters with t in seconds. It says assume a rock is dropped from the top of a 200-meter cliff. Find the speed of the rock at t equals 1 second. And so again, we would use the limit as h approaches 0 of f of a plus h minus f of a over h. But since we're talking about time and speed, they just changed the variable to fit the problem. So the book uses the limit as h approaches 0 of f of t plus h minus f of t all over h, just to fit that we're talking about time. But it's the same steps. So this would be the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. So everywhere I see a t, I'm going to plug in 1 plus h, and then everywhere I see a t, I'm going to plug in 1. So let's see how it goes. So we have the limit as h approaches 0 of 1.86 times 1 plus h squared. So we had to plug in 1 plus h, which we did, but we got to square it to finish off the problem. Minus, now we plug in 1, so minus 1.86 times 1 squared all over h. So remember, this is 1 plus h times 1 plus h, so it's not 1 plus h squared. There's a middle term in there. So we get the limit as h approaches 0 of 1.86 times 1 plus 2h plus h squared minus, and then this is 1.8 times 1 squared, so it's just 1.8 times 1, so it's minus from the formula, and then you put 1.86 all over h. But you can't go and cancel this. It looks like you can, but order operations say you multiply before you subtract, so we have to go and distribute this. So this will be the limit as h approaches 0 of 1.86 plus, and then 1.86 times 2 is 3.72. Don't forget your h. And then plus 1.86 h squared minus 1.86 all over h. Now, addition and subtraction on the same line of order operations, so now you can do this. And we get the limit as h approaches 0 of 3.72h plus 1.86 h squared all over h. And then separate it. And then simplify. So we get the limit as h approaches 0 of, that simplifies, and one of these simplify, so there's one left. So this is 3.72 plus 1.86h then we get the limit as h approaches 0 of 3.72 plus 1.86 times 0. Now h is 0. Don't forget, h is 0. And then anything times 0 is 0. So this is 3.72. But you gotta have some units. And so when it says assume the rock is dropped from the top of a 200-meter cliff, find the speed at t being 1 second, so that's your unit. So the rock, the speed, so the speed of the rock being dropped from a 200-meter cliff after 1 second is, so the rock is at 3.72 meters in that 1 second. So the speed of the rock being dropped from a 200-meter cliff after 1 second. So again, the rock is thrown. At 1 second, that rock is at 3.72 meters down the cliff. Okay. Then at 2 seconds, it'll be double that, and so on and so forth. So the next problem, let's see. You all wanted to see was what? It was number, what, 31? Yes, 31. And it says find tangents and normal. So we need to find an equation for each tangent of the curve of y equals 1 divided by x over 1. I'm sorry. 1 divided by x minus 1. That has a slope of -1. And it says see exercise 21. So in exercise 21, you were supposed to find the slope equation because exercise 21 did not give you what x was. So it was just the slope equation. So we have y equals 1 over x minus 1. And you all didn't ask for 21, so I'm assuming 21 went okay. So the slope equation was -1 over a minus 1 squared. So what 31 is asking you to do is take the slope equation, set it equal to -1, because this is the slope equation. So they're asking you to set this equal to -1 and find x. So it's asking you to think backwards. Where x was normally given, x is not given here. They give you the slope. So now they're asking you to find what x would make a slope of -1. So that's what they're saying. What x would have a slope of -1? Okay, so and then they're asking you to write tangents, or a tangent equation and a normal equation, but the normal equation wants a slope of 1. So the tangent equation needs a slope of -1. And then the normal equation needs a slope of +1. So it's a lot going on in this problem. So what we do know is we need this from problem 21. So if you solved problem 21, this is what you should have got. All right, so we need to find an equation, tangent, that has a slope of -1. And so we use a slope equation that we got from 21. So we take -1 over a minus 1 squared, and we set that equal to -1. All right, so we almost got a proportion. So if I make this into a proportion by putting a 1 under the -1, we can cross multiply, but we need to multiply this out first. Okay, so this is a minus 1 squared. So this is a minus 1 times a minus 1. And that'll give us a squared minus 2a plus 1. So now we cross multiply this. We get, all this becomes its opposite. So we get negative a squared plus 2a minus 1 equals negative 1 times 1 is negative 1. Alright, so if you notice, a is to the second power, and that's quadratic, and so hopefully you know that some factoring has to happen, but we can't do it when our leading coefficient is negative. So we take everything to the other side of the equal sign so that this side can be 0 and then our leading coefficient can be positive. So that's plus a squared minus 2a plus 1. And you do that over here. So it'll be plus a squared minus 2a plus 1. So that equals 0. And then that actually leads us to, and we get, and I'm going to put it in standard form. So I'm going to put a squared minus 2a. I'm going to put my degree first. Alright, so we have no c term. We have an a term, a b term, and we have no c term. So 9 times out of 10, when there's no c term, you can just pull out your GCF. Then when you pull out your GCF, it's factored. If there was a c term, we would have to use the diamond method, but there's no c term, so I just pulled out a GCF. So now we set each term to 0. So this would be a equals 0 and a minus 2 equals 0. So we have to solve this one. So a equals 0 and a equals 2. Now remember, what is a? A is x. So we got a slope of -1, and we have x being 0, and we have a slope of -1 and x being 2. Okay. So again, we worked backwards. We took our slope equation, set it equal to -1, and when we solve for a, which is actually x. So we're almost done. So we have our slope, we have our x and our point, but we need our y and our point. So what do we do here? We plug in x into the original function to get your y. So here, plug it into the original function. So plug this x into the original function to get our y. So this would be 1, because it says y equals, so 1 over 0 minus 1, which is 1 over -1, which is -1. And then here x is 2. So this would be 1 over 2 minus 1, which is 1 over 1, which is just 1. So now we got everything we need. So we got our slope, we got our x and our y. We can write and subtract 1, so y equals negative x minus 1. Do the other side. Okay, so those are our two tangent equations. So we had our slope. It wanted our slope to be negative 1. We had that from here, from the original problem. So we had our slope. We've always had our slope. What we did not have was our x. So, and then we couldn't do our y until we had our x. So again, just a little backwards, but doable. And so now we got to do the same thing for b. So there was a 31a with the slope being negative 1. And there's a 31b, but the slope is a positive 1. And then they want you to find the normal. So with the slope being now a positive 1, that would be the normal equation because that's the opposite reciprocal of negative 1. All right, so let's hit it. Let's do 31b. We're gonna okay, so I'm gonna see if I can squeeze 31b right under 31a because it's just changing the slope to positive 1. So this is tangent. This is tangent. Alright, and then we got to do the normal. So we would change our slope to positive 1. X is still 0. And y is still negative 1. And then the normal is here. This is a tangent. And m is 1, and x is still 2, and y is still 1. So the only thing that changed was the slope. Alright, so okay, that's 31. It was long enough. So let me put that this was 31B. Okay. Alright, so the next problem you all asked to see was 33, and that was the story problem, and I'm just gonna do A through D. Yeah, I'm just gonna do A through D. Um, and then I already took the liberty of, well, I'll show you that in a minute. So A, it asks you to, so they're talking about national defense spending in 1990 through 2003. And it's in the billions of dollars. And so A says, find the average rate of change or the slope from 1990 to 1995. So all right, so 1990 from the table was 299.3 billion, and 1995 was 272.1. So this shouldn't have been too bad because you have ordered pairs. So you just find the slope the regular way. So 272.1 minus 299.3. And we get negative $5.44 billion per year. Okay, so spending went down. All right. B, same thing. I'm sorry, 294.5. 305.5. Alright, so spending went up during that year. Then C, okay, so that's how A, B, and C should have went. So that shouldn't have been too bad. And then finally D, they wanted you to, I went on ahead and did it because I am tired. So they wanted you to make, I don't know if you can see this. I want you to make can you all see this? Like you all can answer me, that's funny. They wanted you to make 1990 0, 1990, and then 1991 was 1, and then 1992 was 2, and so on and so forth. So this is 95, this is 99, and then this is 2000. And so you put it in like that, like Jaden usually, not Jaden, Jonathan usually wants to do. So you put it in like that, and then by pressing stat, I don't know if y'all remember how to do that, but you press stat and then press 1, and then 0 through 13 is starting at 1990 to 2003, and then put your Y values in from the textbook. And then you press that again, go 1 to the right for calculate, and they wanted you to find the quadratic regression. So you press 5. And X is in L1, Y is in L2. So you calculate it, and here is your A, B, and C for your equation. So Y equals 2.1775x squared minus 22.3155x plus 306.4434. Now, E and F, E, you would put this equation into y equals, and because this equation is more accurate because it came from the calculator, so you would put this equation in a calculator and then get the spending for each year from this equation. That's how you would do E, and then you would have to redo A, B, and C. So you would have to redo A, B, and C with the new points that would come from this equation. I don't feel like doing all of that. And then F, it says use the regression equation to find how fast the spending was growing in 2003. You just plug that into the function, plug 2003. I don't know if you plug in 2003. You probably need to plug in 13 into the function, since that's what we changed it to. And then G, it's just saying explain why you would not use this equation, and just for the fact that it could be wars or some natural disaster or man-made disaster, there can't be a fixed equation, because you might spend more than what this equation is calling for. You might spend less, but there can't be a fixed equation over something you can't predict. All right, and then finally, you all asked for number 39. And 39 is the same thing. The answer should be C. They're asking for the tangent equation at x equals 1. So it's the same. So lastly, I am tired. Number 39. See if I can do this really fast. Hopefully I don't lose you all, but you all can pause and rewind. So we got f of x equals 2 over x at x equals 1. So it is asking, and you want the tangent equation. So this should be plenty of practice for this formula. You should be comfortable with this formula. The limit as h approaches 0 of f of a f of a plus h minus f of a all over h. So we've done quite a few problems using this formula, so you should be comfortable. So this would be the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. So So this would be 2 over 1 plus h, because that's where x is, minus 2 over 1, because that's where x is, all over h. And I will leave it as 2 over 1. It's just 2. Oh, well, no. Okay. It might be. So this would be 2 over 1 plus h minus 2 over h. And so the common denominator is just 1 plus h, because this is 1. And so anything times 1 is itself. So this would be 1 plus h. This would be 1 plus h. This would be 1 plus h. So that's gone, and you get 2. Distribute this, and you get minus 2 minus 2h. And then we're going to leave this. Okay, and that's gone, and we get and then simplify that, and we get now I plug in 0. All right, so our slope is negative 2. So B, D, and E cannot be the answer. B, D, and E can't be the answer. So we're only looking at so we're only looking at A or C. So, and we want the tangent equation. So our slope is negative 2. X is 1. And when we plug in 1 here, 2 over 1 is just 2. So y is 2. And we finish it off. Add 2 to both sides, and y equals negative 2x plus 4, which is letter C. Alright, so not going on with this lesson because of this formula, but hopefully with all the problems that we just did, you are comfortable with this formula. And if you have any questions, let me know.